Greetings everyone, this is Mr. Mull, and in this video I'm going to talk about how we're going to write equations in physics. And when we come up with a mathematical model for some experiment, we have to remember that when we look at an equation we get in our calculator, for example 5x plus 6 is equal to y, those numbers and those letters have some physical meaning. They correspond to something that we've done in an experiment. And so we're going to come up with a standardized way to deal with these equations so that we can all speak the same language. The first thing we're going to do is we're going to take all of the variables that we've measured, and we're going to see them in the equation as x or y, and we're going to replace the letters x and y with the variable or the physical property that we measured, and we're going to replace it with that. Example would be mass, length, volume. These are physical properties of an object we can measure, so we're going to replace those with the variables, and we're not going to include units. Okay, so we're not going to put a unit on here. When I say mass, I'm not going to say grams. I'm just going to say it's mass. That's the variable. Gram is a unit of mass, but we're talking about what's changing, and that is the mass. The second thing we're going to do is we're going to take all of the numbers and we're going to add to the numbers units as we need to. And we're going to be adding units to those numbers so that whenever we plug into this function some value for x or y, that we're going to get an answer with the correct unit that we're looking for. And I'm going to do an example with you in a second. So let's look at an example. Here we have an experiment that we did where we made a little ruler, and on the ruler we put some pennies, and what we did is we changed the number of pennies, and we seen how that affected the distance from the center. And so I got this equation, y is equal to 5 over x, and this type of variation is an inverse variation, and we're going to try to give this equation some physical meaning. So the first thing I would do is I'm going to take and do step 1, and that is replace x and y with the variables we measured. So using my idea of dry mix, okay, the dependent variable dry goes on the y-axis, so we have my distance here and my mass was down here. So I'm going to go ahead and replace my y with the variable that we were talking about, and that was the distance. I'm going to put that in parentheses. Okay, variables in parentheses. And I'm going to do the same thing with my x. So instead of putting x, well, x actually stood for some variable, and that in this case was the mass of my object. So I'm going to put the word mass and replace that with x. And we still have that number 5 floating up there. Okay. Step 2, we're going to add units to any numbers as needed, so that when one unit of the x variable is plugged in, only units of the y variable remain. Let's break that down into two pieces. When one unit of the x variable is plugged in, so I'm going to take my function now and I'm going to plug in one unit of the x variable. And so I'm going to go ahead and take my function here, 5 divided by, instead of mass, I'm going to actually put a mass in here, and I was measuring mass in pennies, so I'm going to put 1 penny. I'm just going to plug this in. Okay, we're plugging this in. So this is supposed to, after I plug this into the function, it's supposed to give me some distance here. And now we're going to try to figure out, well, what's this distance unit going to be? It's got to be centimeters. So when I plug something in for mass, I plugged in a penny, I'm going to be getting some value here in centimeters. Now 5 divided by 1 is 5. So when I plug in 1 penny, that's all I did here, I just plug this in, I'm going to get a value. I need a distance as measured in centimeters. So I look at the unit, I look at my number 5, and I notice that right now, if I don't add any units to anywhere, the unit I'm going to get out of this function here is 5 over pennies. But I don't want 5 over pennies. I want a unit of centimeters. So I need to do something. I need to add some units to this number 5 in order to get rid of pennies, because I don't want pennies in my final answer. I want centimeters. And I also want centimeters, which I don't have anywhere. So in order to do this, I'm going to need centimeters in the numerator, as I have in my final answer. So I need centimeters there. But I also need to add units to this same number, 5, so that pennies goes away. So I'm going to actually have to multiply this by a penny. I spelled penny wrong. I'm going to have to multiply this by a penny in terms of what units attached to the 5, so that when I have penny on top and penny on bottom, those units will actually cancel. Okay. If I put a divided by penny, then I'm going to have I'm going to have pennies in two denominators, and it's going to give me some over penny squared function. So I'm going to actually have to multiply this out by a penny. When I do this, pennies go away, and I get 5 centimeters is equal to 5 centimeters. So when I look back at my regular equation, the only combination of units in order to give me centimeters as a final answer would be to put a centimeters on that 5, and also to put a penny multiplied by that 5. With those unit combinations, when I plug in any mass I want, I could plug in 1 penny, 2 penny, 3 penny, 4 penny, 5 penny, doesn't matter. After the units cancel, I'm going to be left with the unit that I want left standing, and that's going to be a unit of centimeters. So I would actually go and add on the unit centimeters times penny, and then this would be my final physics equation. To make sure you've got it, I'm going to do another example. Let's say I do an example where I'm measuring the length of a string and seeing how changing the length of a string affects the period on the pendulum. Okay, so my independent variable again is on the y, dry mix, dependent variable on the x. So the dependent variable, here's my period. Here is my length, and my units are on there. And so now I'm going to do the exact same thing I did again. I'm going to take my equation, and I'm going to first start off by rewriting the equation so that y is actually talking about the variable or the physical property that's changing. So y stood for length. You're noticing I'm not putting a unit on this right now. We're just talking about the variable itself, not the unit associated with it. So length is equal to 5. I'm going to leave a space for some units, and then x, well, the variable at the x was my period, so I'm going to put period, and that was squared. So now what I need to do is I need to figure out, I've done step 1, I've replaced my x and y with the variable associated with that, and then my step 2 is to put units on that number so that when I plug in any period, that the unit left standing is a unit of whatever my y variable is. So in this case, I need to plug out, I need to be looking for a period. Did I do this correctly? Let's see. Dependent variable is on the x-axis. Yes. Okay. So what I'm going to do now is I'm going to, oh, did I do something wrong here? Dependent variable is on the y. Okay. I'm going to have to pause this. So what I'm going to do here is I'm going to remember the acronym dry mix. That means that the y-axis has that dependent variable, and the x-axis has the independent variable. And so what I'm going to do now is I'm going to remember that as I write my equation. So y is the variable on the y-axis, and so I'm going to replace this with period is what my independent variable, my dependent variable was. I'm going to put an equal sign. I'm going to write 5, and I'm going to leave a space for some units, and then I'm going to put for what my x variable was length, and that was squared. You'll notice that I'm not putting units, even though I look at my graph and I would see on my appropriately labeled graph units on those. When I write the physics equation, we're going to leave those units out of there because we're trying to make an equation that relates period and length for any combination of period and length. And so the next step, step 2, is to look at my number and put units on the number so that when I plug in any length I want, the unit left standing will always be my unit of period or my y variable. So I'm looking for a unit of seconds because that's what I measured my period in. So when I take that number 5, and let's just go ahead and going through the rules I said, I'm going to plug in 1 unit of the x variable. So I'm going to plug in here 1 and centimeters was my unit of the x variable, and I'm going to square that. Okay, so I'm going to try to get seconds is equal to, scroll this down, 5 times with some unit times 1 centimeter, and I square this and I get 1 square centimeter. And so I want seconds to come out of this, some number. 5 times 1 is going to be 5. And so 5 seconds is equal to 5. I need some unit combination. Now you'll notice seconds, I don't want centimeters at all, so I have to get rid of this unit. In order to get rid of centimeters in the numerator, I'm going to have to put a centimeters in the denominator of this unit that I'm adding to this number. What that does is it gets rid of my centimeters, my square centimeters. I also, though, need seconds next to that 5. So I'm going to put a seconds in the numerator. And so now when I multiply by 1, I plug in 1 centimeter squared, when this unit combination is on that 5, seconds over centimeters squared, only with that unit combination does everything cancel, leaving me with a unit of seconds left over. So when I rewrite my equation, the unit I'm going to put on that number is seconds over centimeters squared. And what this does now is this allows me to plug in any length I want, 2 centimeters, 3 centimeters, doesn't matter. And when the units have canceled, the unit left standing will be seconds, which is my unit of period, which is what I need. And so this is how we can add units to numbers and change the x and y variables into the physical properties we're representing. I hope that this was helpful.